exact trigonometry ratio values. This is a half square. So you've got a square here, and we draw a diagonal line, and that makes it half a square. This is a half equilateral triangle. So we got equilateral triangle. Again, we draw the vertical line down, creating a right angle here. So that's another right angle, and that's a half, and that's another half. Let's start with the square. If this side is 1 and that side is 1, we can find the length here. All we have to do is 1 plus 1 and we'll root it. That's true actually, but let's see. We can use Pythagoras theorem. This side plus that side, the square of this side plus the square of this side equals the square of that side. So the one we're looking for is the diagonal here. Okay, so that would be 1 squared plus 1 squared equals, let's call that h, d for diagonal, d squared. So that's d diagonal. 1 squared plus 1 squared is basically 2. 1 plus 1 is 2. So d squared equals 2. And that implies d is plus or minus root 2, but we cannot have a negative diagonal, so it's just going to be root 2. So this is root 2, and that works. 1 plus 1 and root it. Perfect. But that's how you find it there. So that's root 2. This angle is 90. So is this angle here, that's 90, and that's 90. So if you draw a diagonal line, you create an angle of 45 degrees. And that too will be 45 degrees. Okay, so now we can apply the trigonometry here. And the first one is sine 45. So sine 45 degrees will be, sine is opposite over hypotenuse. The opposite of 45 is 1, and the hypotenuse is root 2. So that's 1 over root 2. But we know we cannot have a root in the denominator, so we have to rationalize it. So we times it by root 2 over root 2, and that will give root 2 over 2, because root 2 times root 2 is 2. So therefore sine 45 degrees is root 2 over 2, or 1 over root 2. So if we write sine 45, okay, we're meant to remember that that's root 2 over 2. What about cos 45? Well, let's do it with another pen color. So cos 45 is going to be, well, cos 45 is adjacent over hypotenuse. Car, C-A-H. C for cos, A for adjacent, and H for hypotenuse. And that will be 1 again over root 2, and that equals root 2 over 2. So cos 45 equals root 2 over 2. So it's basically the same as sine 45. What about tan 45? So tan 45, two ways we can solve that. We can actually do it from here. So let's do tan 45. Tan 45 degrees is, tan is opposite over adjacent. TOA, T-O-A, opposite over adjacent. And that will be 1 over 1, which is 1. So tan 45 is 1. Another way of doing tan 45 is to say, well, tan 45 degrees is sine 45 degrees over cos 45 degrees, and that gives root 2 over 2 over root 2 over 2, and they cancel out and you get 1. So tan 45 again is 1. So that's how you work out the half square angle. So we're meant to remember this. So we're meant to remember tan 45, cos 45, and sine 45. So tan 45 equals 1, cos 45 equals root 2 over 2, and sine 45 equals root 2 over 2. Now let's go for the equilateral triangle. We're going to look at a half there again. So in this case, let's say this is 2, 2, and that's 2. Obviously that'll be 1, 1, because equilateral triangle, equal sides and equal angles, 60, 60, 60. So if this is 60 here, that must be 30 degrees. At the same time, we need to find a height here. Again, 1 plus 2 is 3. That should be root 3, but let's prove it. So again, this is the height. Definition actually is the area of that plus the area of that equals the area of that. So we could say, well, 2 squared equals 8 squared, right, plus 1 squared. So that's what that is meant to be. And then therefore h squared equals 2 squared. You move the 1 to the other side, minus 1, and that equals 4 minus 1, which is 3. And therefore h equals square root of 3. So that will be root of 3. Okay, so, or you can say 1 plus 2 is 3. There we go. Right. So that's the height. So now we can find the trig ratio here, the exact value. So we could start with sine 30 degrees. Sine is opposite over hypotenuse. Opposite of the angle you're looking at, opposite over hypotenuse, which is 1 over 2. So sine 30 is a half. What about cos 30 degrees? Well, cos 30 degrees is adjacent over hypotenuse. Adjacent over hypotenuse. So that's root 3 over 2. What about tan 30 degrees? Tan is opposite over adjacent. 2r. Opposite over adjacent. 2r is opposite and a is adjacent. So therefore it's going to be 1 over root 3. But we cannot have root 3. We need to rationalize the denominator. So that will be times root of 3 over root of 3. So that will be root of 3 over 3. So that will be root 3 over 3 for 30, tan 30. We could check with a calculator to just see what we got if you do tan of 30 degrees. Put it on, put tan 30, close the bracket, root 3 over 3. Okay, right, so that's tan 30. What about 60? Well, we could try that for sine 60. So for sine 60, sine 60 will be, right, so 60 sine opposite over hypotenuse. So that'll be root 3 over 2. What about cos of 60 degrees? Cos 60 is adjacent over hypotenuse. So that's a half. Okay. And the tan 60 degrees is opposite over adjacent, which is root 3 over 1, and that's root 3. So we're supposed to know those. And these values, you can work them out or you can just remember them. Sine 45 is root 2 over 2, cos 45 root 2 over 2, tan 45 is 1, sine 30 is a half, cos 30 is root 3 over 2, tan 30 is 1 over root 3, which is root 3 over 3. Sine 60 is root 3 over 2, cos 60 is a half, tan 60 is root 3. Okay, we know that also that sine 0 degree is 0, cos 0 degree equals 1. Therefore, tan 0 degrees, well, tan is sine over cos, which is 0 over 1, which is 0 degrees, 0 as well. Sine 90, we know is 1. Cos 90, we know it's 0. Tan 90 degrees, we know tan is sine over cos, that'll be 1 over 0. 1 over 0 is undefined, so it's what you call the line of asymptote. So it's undefined. It's the line that the curve approaches but never touches.